Hey guys, so I just wanted to talk quickly on the concept of ethnomathematics. And apparently, ethnomathematics is the field of I guess, the study of uh, how culture affects mathematics, how different cultures, different ethnic groups may have approached mathematics. Kind of goes to the broader question of, is mathematics discovered or is mathematics invented? So if you get into the whole thing, is mathematics discovered, it's just this reality that exists out in the universe and is waiting for people to discover it, much like the laws of physics or chemistry. But if it's invented, then from whatever culture you come from, whatever background you come from, you're going to invent the mathematics or create the mathematics influenced by that. And this really isn't quite my field. My background isn't math education or math philosophy or history of mathematics. So I'll just come at it from someone who has, I guess, a practitioner of mathematics and someone who's taught mathematics, but not necessarily math history or philosophy or logic or whatever, at least not in an in-depth way. So just from my background, I will say I think that mathematics is a combination of discovered and invented. I do think that there are certain. I think mathematics is a way of translating ideas and concepts. So I just use an example of language. We have the word happy, content, but the idea or the feeling of contentment or happiness, they exist independent of those words. So it wasn't like you had to come up with the words to have those ideas. So I think that's kind of the way mathematics is. Now, through mathematics, do we teach possibly to look, I guess, to focus on some cultures more than others? Do we say that maybe not intentionally, that other cultures may be superior or whatever than other cultures through mathematics? And I don't know. My initial attitude towards that would be dismissive. But reading a little bit about that, I think there may be some weight to that. But that's really going into a whole different thing. I'm not nearly as dismissive of that possibility as I used to. I used to be, I should say. Now, as far as the effects that culture has on mathematics, it is profound. And one thing that ethnomathematics says is that maybe we should teach mathematics from a perspective of different cultures. And I say absolutely. And I'll give an example from the past of where this was important and why we should do it now, in my experience. So, past why it would be important is the number system we use. So, the number system we use comes from the Hindus and the Arabs, and actually was introduced, to my understanding, it was introduced to the Arabs and the Persians through the Hindus, and we adopted it. So, if you look at the numbers that are used in the Arab world, they do not superficially look like ours, but it's the same system where it's a base 10 system where they have 0, 1, 2, and so forth. So that was not a European invention and was actually popularized, or I guess, yeah, popularized, I guess that's the word I'll use, by Leonardo Fibonacci. I want to say the 12th century. Fibonacci as in the Fibonacci sequence. Now, why is it that the Hindus created this system? Which, here's an invention of that a number system is zero, right? So if you look at there's no Roman numeral zero. Think about it. There's no Roman numeral zero. There's no. I think the Greeks will use letters for their numbers. There's no Greek letter that represented zero. So some people speculate that the idea of zero, of nothingness, of an emptiness, in the concept of how we use it in mathematics, where it's not quite a nothingness, because there is a thing in mathematics where it's the null, which is nothing, but zero saying you have no more. So philosophically, those are different. That the reason this was developed maybe by the Hindus is because of maybe their religion, the idea of something, nothing, I don't know. But I do know that you have thousands of years of Greek, Roman, European mathematics, and you didn't have that concept of zero in that way. Did you have a zero? Yes, but did you have a symbol representing that zero? It took the Arabs and the Hindus for all the knowledge, for all I know. Also, well, so that's an example of where I think where culture influenced mathematics, and looking at how other cultures looked at that mathematics, how it was beneficial. I think another way, just I could probably give dozens and dozens of examples, but I'll just give one more. Is something I didn't know until recently, and it's something as basic as quadratics. So if you were in college algebra or algebra 1, maybe 2 in high school, you had quadratics and you had to solve for the quadratic. So you were given some second degree polynomial and you had this set equal to 0. Something I didn't know is that is before there were, this before they had the Roman numerals, well, how would you solve a quadratic? And I guess in my mind I just said, well, maybe they didn't have quadratics. I know that they had algebra. They had the concept of algebra, and that was another Arab invention. But maybe they didn't have the quadratic. And it turns out they had the quadratic. Well, did they use these, numbers or, Roman numerals or Greek? No. Actually, the way they depicted quadratics was using geometry. And a quadratic, the leading polynomial or the leading term in a polynomial or quadratic equation is a squared. So it would literally be a square, and it would be the area of a square. And I don't know exactly how would be done. I've seen it. I've seen quadratics being worked this way, but I've never worked it myself. But that's amazing to me, because I guess if your background is geometry and seeing mathematics or the approach of mathematics as object in space, then that's the way you would work the problems. So I think what happens is if you're coming up with different problems, if you're facing different problems, and you have kind of these different ways of conceptualizing it, then you can pull from these things, because if I'm approaching a problem, I'm approaching it symbolically. And what I mean by symbolically is quadratic equation, I'm seeing the numbers, and the numbers are representative, and the x is representing them. So those are the symbols, right? But to even think of that geometrically, it wouldn't even cross my mind. So are there some problems out there that are unknown that will come up where it turns out the solution or the best solution is geometrically? It is some conception that I was never taught. But if I had, was brought up in a different culture or whatever, then I would see it being, I would see mathematics being performed this way, and solving that problem would be easier because of that. So my very shallow and I guess shallow opinion of ethnomathematics is, yes, culture affects mathematics. Yes, I'll say that certain cultures, their approach to mathematics, how we're taught mathematics, it is emphasized to the detriment of others. And I've even seen that. I've seen when we teach calculus, how we teach the finding the area under the curve, we attribute that all to Leibniz and say, well, differential calculus comes from Newton. But the reality of it is that there were Chinese philosophers and mathematicians, scientists who were actually coming up with methods of calculating the area underneath curves, I think hundreds of years before Leibniz came around. And we'll say, well, they never came up with the fundamental theorem of calculus. Okay, they didn't come up with the fundamental theorem of calculus, but they did come up with this method of finding curves by segmenting the area into rectangles and further rectangles. So we dismiss that. We dismiss the mathematics that were taught there, and we focus on these two, albeit brilliant, but two European guys. And then lastly, if you want to make good mathematicians or just good thinkers in general, show how different people approach these problems, because just for the purpose of being able to conceptualize problems in a way that you may not before. And I think that would be important, like the quadratic equation thing. I've taught mathematics mathematics in higher education for over 10 years. And I don't know, I've spent a decade in undergrad and graduate doing mathematics, and I'd never seen that before. But anyway, thank you.